Hello science student, welcome to my new science school chemistry class. In this class we are going to look at chemical combination. This topic is very important in chemistry, and understanding chemical combination will help you to know how reactions occur in chemistry. In our previous lesson, we described the electronic configuration of atom. We said that electronic configuration is nothing but showing number of electrons, number of shells, and also the nucleus of an atom. Let's say this is the nucleus. This is the first shell. This is the first shell, second shell. And we said that electrons are on these shells. Let's put this X sign as the electrons. So the first shell, which is the innermost, this one, it is capable of taking only 2 electrons. So we have 2 electrons. Outermost shell here can contain 8 electrons, so we put 8 here. So this electronic configuration of neon, and this electronic configuration of neon is just that the electrons are 10 and the atomic number 2 of this element is 10. And the number of electrons outside or in these shells correspond to the number of protons inside the nucleus. Generally, the number of protons is the important number that will indicate or that will tell you the number or atomic number of that element. So if I say neon has atomic number 10, then this is telling you that this neon contains 10 electrons, it contains 10 protons in its outermost shell, and which is also the same number of electrons. And we explained that this 10 number of electrons, this 10 number of proton inside the nucleus of this cell, nucleus of this atom, when the atom is neutral, this is neutral atom. When the atom is neutral, number of proton, let's say number of P, is equal to number of electrons E. Let's say we have proton as 10. Then if the atom is neutral, then the number of electrons too, they are going to be, let's say number of electrons, they are going to be 10. So if you do simple mathematics, you said 10 minus 10, you get 0. That 0 means there is no charge. This electron, as we said in our previous videos, we said it has negative charge, while proton has positive charge. So now comparing the two, you have positive and negative. Positive and negative will cancel one another. At the end, you'll end up having 0 charge. That's the reason we always just write let's say this is neon, we just write neon without putting any charge. But in a situation whereby you have the number of electrons are not up to the number of protons, then you have charge. Or you have the electrons are more than number of protons, because proton and electron has all of them have the same but opposite charge. Let's say this has 10 charge, this also has 10 charge, but this one is positive while this one is negative. This is telling you that if you have 10 plus and 10 minus, then you end up having only or you end up having 0. So in the case of ion, as we explained in our previous video, we said that ion is when the atom has unequal or imbalanced charge. These imbalanced charges can be positive or negative. Let's take example. We're just trying to explain this in order to help you understand, or if you understand this, it will be easier for you to understand the chemical combination. Ion, let's just take sodium as example. Sodium is N. This is sodium, and this sodium is neutral. How? Because we have proton. Let's say proton is equal to 11, electrons is equal to or are equal to 11. At the end you have 0 charge. That's why we left this sodium as just sodium without putting any charge. But in the case where you have the number of electrons are less than the number of proton, for example, let's say this is the neutral. Let's give this as neutral, and here you have proton as 11 and you have electrons as, let's say, 10. Then at the end you have net charge of +1. Why is +1? Because these proton, they are positive charge as we explained earlier, and this electron are negative. So it's just like saying +11 minus 10. +11 minus 10, if you press your calculator, you end up getting +1. That's why we said you must pass our, or you must watch our previous lessons, or those lessons that we term, or that we call them in general. All of them we call them as basis of calculations, because from basis of calculation we explain all this, how you do all this addition and subtraction. So you have +1 as the charge. So if you want to say, or if you want to tell us that this sodium has charge, you just put the plus here, or +1. But we don't usually put the plus here. We just leave it as plus. So this is charged sodium. Why is it charged? Because the number of electrons are less than the number of proton, and it depends on how many electrons are deficient there. So now let's take another example. You have your sodium, but now you have proton. Okay, let me change the color. Let me put red. Proton are +11. Let me use the plus now, since you understand the meaning of it. And now you have 12 negative. You have 12 negative. Then the net charge, when you press your calculator, you have when you press +11 minus 12, you will have -1. Your net charge is what? -1. Then your sodium will be, okay, let's put it here. In this case, your sodium will be, instead of just sodium, it's going to be sodium minus, because you have -1. How do you get minus or plus? Is because, or is through increase or decrease number of electrons, unbalanced number of electrons, unbalanced charge of electrons by proton. So proton and electrons, they are the ones that will determine if this atom is going to be charged or not. When atom is charged, it is called ion. So ion is just charge form of element, or charge form of atom. If you have hydrogen, it's just neutral, but putting plus here is not hydrogen, it's hydrogen ion. So this is hydrogen atom, but this is hydrogen ion. How do you write ion? It's just ION is ion. So we have hydrogen here, hydrogen, and we have hydrogen ion. Hydrogen ion. This is just how you write it. So anytime you see a charge here, or either plus or minus, just use the word ion in front of the name of that atom. So this ion can be +2, can be +1, depending on how many electrons are deficient, or how many electrons are in excess. So now you understand charges, and we also understand electronic configuration. So imagine this is neon. This neon is neutral. Imagine you remove 1 electron here, then this neon is deficient of 1 electron. And if it is deficient of 1 electron, that means protons are more than electron. Then you will have positive charge. Why? Because protons are positive and they are more in number than the electrons. So you have positive charge. But this is not practical, because neon always maintain the 10 electrons. So now let's talk about chemical combination. Chemical combination now happens when there is change in number of electrons. As we said earlier, let's take hydrogen as example. We have this is hydrogen. This hydrogen is not stable. Why? Because this hydrogen will always trying to attain diplet electronic configuration. What is diplet electronic configuration? Is the tendency or is the urge of atom to fill its innermost shell, which is this shell. Atom does not want to see this shell with only 1 electron. It always want to fill that electron to make it 2. So in the process, this hydrogen, let's say this hydrogen is just neutral, but when it acquires electrons here, in order to see that it is of doublet side, then you doublet number of electron, that is double number of electron in that innermost shell, then you have 2. Adding this 1 electrons, remember 1 electrons means when it is 1, before putting this electron you have neutral, but now you add another electron. Adding another electron, remember electron is negative. Adding negative will make this hydrogen to be negative. So putting another electron here will make the hydrogen to be negative ion. So you have hydrogen, but here is the ion is negative. So you have hydrogen ion nevertheless. So that means all atoms that need to complete their outermost shell, they will either gain or lose electron. What is gain? This is how to spell gain. Gain or lose electron. Okay, let's take hydrogen. You have, this is the nucleus, this is the first shell, this is second shell. Second shell always want to fill the for this atom to remain stable, you need to fill the shell. So you have here electron, here electron, here electron, here electron, but this space is 1, this space is 1. You have only one electron. So this atom will always need 1 electron here and another one here, so that it will maintain the octet electronic configuration. What is octet? Octet means 8. Octet electronic configuration. This is, we have 2, 4, 5, 6, and it needs to make the outermost shell. This outermost shell is not complete. The number of electrons are not enough. It wants this number of electrons to be 8. That's the name octet. So making octet means to make the number of electrons up to 8 so that it will fill the shell. Filling the first shell, just you need only 2 to fill it, but filling the outermost shell you need 8. That's why we said the first shell, filling the first shell is doublet. Filling the last shell or the second shell is octet. So doublet electronic configuration means this, like to have this electron and this electron. But when you say octet electronic configuration, you means this shell will contain how many electrons? 8 electrons. So in this case, this hydrogen will look for electrons anywhere from any atom, and he can get one hydrogen atom. For example, hydrogen has only 1 here. So this hydrogen can even give hydrogen oxygen. Sorry, this electron can be transferred to oxygen, so that oxygen will become 7 here, and another hydrogen atom. Let's say this is hydrogen, and another hydrogen atom. Let's use this. Another hydrogen atom will give this electron to this part, and this in this condition you have, let me put the electrons here. This, I put this electron, let me erase it from here, and let me put this one here. So in this process you have only proton here with no electrons. So if you are counting to see is this ion or not ion, you will see that this is ion but with positive here. Why is it positive? Because before, when there is X there, the atom is neutral, but removing that means this is negative. So when there is negative charge there, the atom is neutral. But now I remove the charge, which is negative, but the atom now must be positive because it lost that negative part that would balance the positive side. So you have, this is plus, you have hydrogen ion. Here too the same thing, you have hydrogen ion. You have hydrogen ion. So imagine you have hydrogen ion as plus here, while this oxygen, it has only 8 proton and it has 8 electrons before, but you add 2 electrons to it, so you have now 10 electrons. You have only 8 proton, but you have 10 electrons, which makes it -2. Now you have -2 here, you have +1 here, you have +1 here. Adding everything together, you will see that oxygen here will have -2. Hydrogen here will have +1, sorry. Hydrogen here will have +1. So this in nature, whenever there is negative and positive, they will meet together, they will attract each other. So this will attract with this will attract with this, and they end up forming what is called chemical bond. So chemical bond in this case happens because of electron transfer. You transfer electrons from hydrogen to oxygen, making the hydrogen positive and making the oxygen negative. That's for first hydrogen, and for the next hydrogen is the same thing happens. You have negative, which is hydrogen, oxygen. You have two positive, which are hydrogens. Then you have reaction. But this one is not good example of it, because this one is not the way these two elements react. Good example is when you have sodium and chlorine. This electronic configuration of sodium, let's draw sodium. But now I don't need to put all the electrons that are in the inner shells. For the sake of understanding, let me just complete it. So this is the shell, this is the first shell. You have 1, 2, then you draw another one, then you have this, you have this, you have this, you have this, you have this. Next, you have 1. This electronic configuration of sodium. Then for chlorine, you have nucleus, you have 1, 2, then you have another shell, you have 1, 2, 3, 4, 5, 6, 7, 8. You have 8. You draw another 1, 2, 1, 2, 3, 4, 5, 6, 7 here. So you have 17. You have 11. You have 17 electrons, and in this case, all of them are neutral. That means the number of electrons balance the number of protons in the nucleus. So you have balanced. But this chlorine will need only 1 electron to fill this outermost shell. That's it has very intense affinity to that electron. It will look anywhere, everywhere, just to see 1 electron in order to complete its outermost shell. It will not stop. That's make it very, 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 very reactive. And this sodium too, it has only 1 electron on its outermost shell. Having 1 electron on its outermost shell, it will not stop. It will say, I can't stay with this only 1. It's just like taking it to 8, and you just want to see that the outermost shell is complete. So this sodium will say that it is better to leave or to give out this electron in order to maintain the electronic configuration or octet electronic configuration of this outermost shell. So it can easily give this electron, while chlorine will need that 1 electron, because chlorine now, to maintain the octet electronic configuration of the outermost shell, is just by getting 1 electron. But for sodium, for it to maintain its electronic configuration of octet, it needs 7 electrons, and it's very difficult for it to get 7 electrons. That means when to fill the shell is you need more electrons than the electrons that are there already on the shell. The atom will give out the electrons to other atoms so that they will fill their own. So imagine you have 4 here, you have 4 here, all of them are 8. Okay, you have 8 electrons to fill the shell, and you want to share, or you want to decide who is to receive. And among these 8, let's say Mr. B has 3, and Mr. A has 3, Mr. B has 5. Now, if you want to judge that somebody should at least give out his remaining, so that 1 will complete, and among these, which one is more likely to give out? Is 3 that will give out to 5. It's like investment. investment now. You are investing. The person that has the highest amount, the highest share, will control the company. So now between A and B, which one will control the company? Is B, because B has 5, because it is it has more shares than the A. And when it comes to A has only 1, let's say A has 1 while B has 7, then A is more likely to even keep quiet and leave B to control everything, because B now has the almost everything. And when they have 4, when this one has 4, this one too has 4, then there is fight between them. Who will control? There will be fight. So in this case, all of them, this can give this one with equal tendency as the way this one will give it on to A. So that's exactly what happened to this atom. Atom that has more number of electrons on its outermost shell, it's easier for it to receive electron than those that has only 1. So in case of hydrogen, in case of sodium and chlorine here, chlorine has only 1 electron, while sodium has only 1 electron in the outermost shell. It is easily going to give electron to chlorine. This tendency of it giving is very high tendency, because it only has 1 electron. It will not even look for somebody to give it 7 electrons to fill this shell, because it has only 1. So it will always be looking at somebody, will only be looking for an atom that will receive 1 electron, so that they will, so this is what happens. So hydrogen, sodium will just give chlorine. So at the end, chlorine will gain electron. And gaining this electron, remember the number, how the charge is balanced. We have 17 of proton, 17 of we have proton before gaining of electron. Before gaining of electron, chlorine has 17 proton, and electron too has 17. Then you have, now you add electron. You have new number of you have another electron, which will become 18. So you have 18 electron, while proton are still 17 or are 17. Then if you do the mathematics, you will have -1. So that means after gaining electron, chlorine will become, instead of just staying chlorine neutral as it is here, you will get just -1. And in case of sodium, we have 11 before, let's say before transfer, you have 11, proton are 11, p are 11, electrons are 11, but now you lose 1 electron to this side of the, or to give chlorine, then you will have 10. You have 10 electrons. So when you subtract 11 positive and you subtract 10, you will end up having +1. That's the reason we put, or this sodium will become +1. At the end, you have 2 oppositely charged ions, because this one is not atom again, it is ion, as I explained in the beginning of this video. And this one too is ion, but this one is negatively charged ion, while this one is positively charged ion. So if you have these types of ion in a container, they will attract each other. The way, okay, let's say we have sodium plus and chlorine, okay, and chlorine Cl minus, they end up producing a compound called sodium chloride. This is chemical reaction. How this reaction happens is because we have sodium ion and chlorine ion. This is called ionic bonding. We have ionic bonding. Ionic bonding. Remember, the name of this is ion. The name of these two is ion. So you have two ions that react together. They are called, or the process is called ionic bonding. So ionic bonding happens between two or more ions. Here we have sodium ion plus chlorine ion. How do you arrive at sodium ion? It's just by simple electron transfer. How do you arrive at chlorine? It's just by electron transfer too. So this atom or this ion is gotten by sending away or giving away its electron. That is called donor. When we say donor, D-O-N-R, that means donor. That means somebody that will give. For example, you go to hospital and you give blood, you are a donor. Somebody will donate organ. You are, or he is, or they are donor. So donor is sodium. Sodium gives electron to chlorine. That is donor. Then chlorine is called recipient. Recipient. That means somebody that receives something. So you have donor and recipient. So in ionic bonding, important thing to remember is we have electron transfer. Electron what? Transfer. And we have two species. We have donor and recipient. So this is just for ionic bonding, and you can work it out for most of the chemical reaction that we see in chemistry. I hope you understand this lesson. If you do so, please, as always, like and share and comment. Then subscribe, open notification for more of this video chemistry. Remember, this lesson is just a random lesson. It's not a lesson under the series we are preparing for you. We are preparing series that will start from lesson 1 up to the end of chemistry syllabus of secondary school. So if you like them, please go and start watching them. You will find them on the in my new science school page on YouTube. So go and watch this lesson. If you like what we are doing, as I said, please like, share and subscribe. This is just ionic bonding. In our next class, we are going to see more example of ionic bonding. Then we look at the next types of bonding, which is the covalent bonding. Covalent is also another interesting types of or interesting form of bonding. Thank you very much. See you in the next lesson. My new science school. As always, we wish you very good luck.